So for the difference quotient part 2, let's call this difference quotient part 2. We're going to kind of finish up something. I want to show you the I want to show you where this goes. We have the limit of, I'm using the word limit. That's a reflex for me. When we're evaluating the difference quotient, if h equals 0, I told you that gives us a function that will give us the rate of change. That function is called the derivative function, and I'm rushing through this. In calculus, you'll spend a lot more time developing what we're doing today. But I want to start off today by working number 7 from our homework last night. So number 7 was, do what? Oh, we're still just the difference quotient. The video will be difference quotient part 2, but f of x equals x squared minus 4x plus 3. Right, and we're told to find and evaluate the difference quotient. Find and simplify the difference quotient, which is f of x plus h minus f of x divided by h. And we said yesterday that there are 3 parts of this thing. We've got f of x plus h to deal with, minus f of x, which we were given, and then h is just, it's the amount of change. Remember, that's the amount of change between the 2 points, x and x plus h, f of x plus h. And this difference quotient is the slope of the secant line of that function, or the average rate of change between these 2 points, or between 2 points on the graph of f of x. All right, which in this case is a parabola x squared minus 4x plus 3. So just kind of rewinding and giving a little context. The first part of this difference quotient is f of x plus h, which will be what? X plus h squared minus 4 times x plus h plus 3. That's the first part, right? What we just did there is f of x plus h minus f of x. What is f of x? F of x was given to us. It's x squared minus 4x plus 3. And all this is being divided by h. Have y'all ever listened to any like videos, math videos of English-speaking people? You know how they say that letter in England? H. That's so weird. H. All righty. I prefer the Spanish pronunciation. Eche. All right. All right, x plus h, x plus h squared is x squared plus 2xh plus h squared, right? Because that's x plus h times x plus h. Sorry, okay, I'll stop that. Distribute to negative 4, we get negative 4x minus 4h. Now I can't stop. Minus x squared plus 4x minus 3. When we distribute to negative 2, f of x, all this is divided by h. Right? Now, as promised with polynomial functions, everything that doesn't have an h will cancel out. So the x squareds cancel there. You got x squared minus x squared, negative 4x plus 4x, positive 3, negative 3. And all we're left with is 2xh plus h squared minus 4h divided by h. And now we can factor an h out of everything, and we get 2x plus h minus 4. So that's the difference quotient simplified. All right? Now, I told you that if we substitute 0 for h, once we get this to a point where we can substitute 0 for h, it gives us a special function that gives us the rate of change of the graph of f of x at any point x on the graph. All right, now, did you notice any patterns in your homework last night?
The x is canceled? Or no?
Okay, yeah, I mean, that's good. If you do it correctly and you're dealing with a polynomial function, everything that doesn't have an h will cancel in this process. Very good. Yes. Did you notice a pattern between the problem and the answers? Emily?
I mean, I don't know if this is all the time, but none of them are ever like over h, and h always seems to be like...
The h has to cancel somehow in order to make a substitution for h equals 0 because we can't have a 0 in the denominator. Meredith, did you notice anything?
I just consider h cannot equal 0. Which...
Right, good. What about you, Ethan?
Anytime there's an x squared, you can always factor out an h at the end of the problem.
Right? You'll always be able to factor out an h at the end of the problem. What was number 5? Number 5 was what? F of x equals just plain old x squared, right? And what did you end up getting? 2x plus h, right? This gives us 2x plus h if we do the difference quotient, which means if we let h equal 0, f prime of x is just 2x. Okay, now do you see any patterns here? Emily?
Like when it's 4x, the answer is 4. When it's 3x, the answer is 3.
Beautiful. That is definitely a pattern, right?
The negative 4x, it's negative 4 is part of it. So
There you go. All right, so we're seeing a pattern. Number 1 and number 3 were just linear functions. We end up just getting the slope, right? Now what do we have here in back-to-back in problem number 5? What do we have? F of x equals x squared. What's our derivative function or our slope function going to be? X squared gives us what? 2x. What did this x squared give us? 2x, right? Where does this negative 4 come from, Emily Tupper? Where does this negative 4 come from right here? The slope of this linear term is negative 4. Right? So it appears that we have a pattern emerging here, right? It appears that we have a pattern. So number 1 and number 3 that you worked for homework were linear functions, and the difference quotient just gave you the slope, the coefficient of x. All right? And that stays consistent when we're doing composition of a quadratic and a linear function, right? If this was x squared and 4x, then we could say that we're doing two functions together, right? So the slope of this first part, the slope of x squared is 2x. The slope of negative 4x is negative 4. And so we're got the pieces kind of coming into play here. All right, are you with me? So what we're going to do this very quickly because we're kind of getting beyond what I'm going to expect you to know. I want you to be able to evaluate the difference quotient. Not evaluate. I want you to be able to simplify the difference quotient for a polynomial function. But what I want you to kind of do now, what we're doing now is really going on a little bit further into calculus just to show you the types of things you'll be doing in calculus with your polynomial operations and algebra skills. Okay, so at this point, we think that we've established that if the function is x squared, then the derivative function or the rate of change function is going to be what? 2x, right? And we know if it's a linear function, then the derivative or the rate of change function, the difference quotient function, is going to be just the slope of the linear part. Okay, and that's where we got this kind of composition of things right here. Okay, now, so let's see if we can extend this, and we're going to do this quickly using what we know about binomial expansion. Let's do f of x equals x cubed. You need to write this. Does anybody want to take a guess at what the difference quotient might be once it's simplified? You think there's going to be a 3 involved? So, and you're taking that saying x squared gave us 2x, so you're thinking that maybe this will give us 3x. Let's see. All right? Let's see. So the difference quotient will be f of x plus h minus f of x divided by h. And I'm going to come over here to the side real quickly and do Pascal's triangle. So that 1, 3, 3, 1 there is going to give me the coefficients of my cubic expansion, right? So, and I'm going to need that because f of x plus h is x plus h cubed. F of x is just x cubed over h. Okay? And using our binomial expansion skills, x plus h cubed is going to be 1x cubed plus 3 what? X squared h to the first, so good, plus 3x h squared plus 1h cubed minus x cubed, all divided by h. Now, as it did with all of our polynomial expressions or functions that we worked with yesterday, the non-h terms are going to cancel each other out, right? The x cubed and the minus x cubed, these two things are opposites, and so they go to 0. And what we're left with is just 3x squared h plus 3xh squared plus h cubed over h, which simplifies to be 3x squared plus 3xh plus h squared. Okay, and what does that give us? If h equals 0, what does that give us? We get this rate of change function. This is what we're calling it in this college algebra class, is 3x squared. So we were close, right? We had the 3 correct, but we had the exponent wrong. So x squared gives us 2x to the first. X cubed gives us 3x squared. Anybody want to take a guess at what f of x equals x to the fourth may have as a rate of change function? 4x cubed, right? Now, just to kind of put this to rest, let's see. Let's let f of x equal x to the fourth. We need one more row on our triangle up here, right? 1, 4, 6, 4, 1 to do the fourth expansion. You with me, HH, Heather Hughes? 1, 4, 6, 4, 1. So f of x plus h, I'll have to write small here, f of x plus h minus f of x over h is going to give us x plus h to the fourth minus x to the fourth over h, and x plus h to the fourth, using our binomial expansion skills, is 1x to the fourth plus what? 4x cubed h plus 6
x squared h
x squared h squared plus 4xh cubed plus 1h to the fourth minus x to the fourth over h. Now we can kind of cut to the chase, can't we? All right, these are gone. We're going to cancel an h out of everything, right? So this h will be gone. That's h to the first, that's h squared, that's h cubed. That's gone. And what are we going to be left with if h is 0? We're going to have rate of change function, which is 4x cubed. Okay? You see how you use this rate of change formula, this difference quotient, the slope of the secant line, getting 2 points getting closer and closer together at h being 0, gives us a pattern that emerges here, right? A pattern for polynomial functions. And the pattern is if f of x equals x to the n power, then f prime of x equals what? Tell me what the pattern is. What would x to the fifth be? 5x to the fourth. X to the sixth would be 6x to the fifth. So what's x to the n going to be?
X to the n minus 1.
N times x to the n minus 1. Beautiful. Okay, and that is actually one of the rules for differentiation. Probably the most, and I just use words y'all don't even know. It's probably one of the most important rules for differentiation. That's what we're doing in here, finding a differential function. Differential, difference. Y'all seeing difference, differential? You see the root word is difference. Rate of change, change, difference, differential, derivative, all those things, calculus terms for what we've done here is found a pattern using the difference quotient that gives us a function for an instantaneous rate of change. That's what you're going to do in calculus. You're going to do this with square root functions. You're going to do this with rational functions. You're going to do this with trig functions. Next semester in trig, I promise we're going to do a couple, when we get into the identities parts of trig, we're going to do a couple of difference quotients with trig functions. Okay, if f of x is sine of x, what is sine of x plus h minus sine of x over h? We're going to work on that. All right? That's where we're headed. Any questions about this? All right, now it's a little bit of a stretch. It's a little bit of a stretch, but, and this is really cheating. Your calculus teacher might hate me for what I'm showing you here at this point, but I don't really care. Can you imagine doing the difference quotient for that function?
No.
X plus h to the sixth plus 5 times x plus h to the fourth minus 3 times x plus h squared minus 6 times x plus h plus 2 minus x to the sixth minus 5x to the fourth plus 3x squared but plus 6x minus 2. There's a lot of algebra involved there. Okay, so you establish patterns that help you go straight from that to this. All right? And what we're cheating on here is the properties of limits, and we're cheating on a lot of things here that you'll learn in your calculus classes. But what would this give us? What's the rate of change function for that one? 6x to the fifth. What do you think this next one would be?
4x to the third.
Times
5.
5, so it's 20x to the third The next one would be minus 6x. The slope of negative 6x is negative 6. And the slope of a rational function, a constant function, the slope of a horizontal line is 0.
Wait, what?
So that's
I did
it.
the very last part with the slope. How do you get that?
Slope of what?
You put in you said what's the slope of negative 6x, and then you put the negative 6 in. I just wasn't sure what happened.
Yeah, the slope of negative 6x, if that was just a linear function, y equals negative 6x, what's the slope?
Negative 6. And
Negative
is
6,
that what you
yeah.
put down?
Yeah, so these are the pieces. So that's how polynomial differentiation works. All right? So that's kind of that's the final part of the difference quotient. I just wanted you to see where it's going so that when you get there, it's not a complete surprise to you. Some of you, if you took pre-cal, then you might have done a little more of this in pre-calculus than we've done here. Pre-cal is a little better is a little better at preparing you for calculus than this college algebra and trig. But because a lot of people that take college algebra don't go on to take calculus, so they make it easier to get through it. But you got a good calculus teacher, you'll be fine at this point. Okay? Any questions?